In this video, we'll explore the idea of finding zeros of polynomials some more. Namely, let's focus on this example, how we can find possible zeros using rational zeros test versus finding actual zeros a little bit later. So in order to find possible rational zeros, what we focus on is the constant term, which is 6 in this case, and the leading term, which is 4x cubed in this case, namely the leading coefficient. So what we want p, the numerator of our rational zeros. What we want is the factors of the constant term, namely factors of 6. Now they could be positive or negative numbers, so we actually have positive, negative, 1, 2, 3, and 6 that all go into 6. And that's what makes up the numerator for our possible zeros. And q are factors of the leading term, which is positive and negative 1, 2, and 4 that go into 4. So we're going to form possible zeros, which basically we can try to list all the numerators right here over each one of these denominators periodically. So first we'll list each one of them over 1, which is we have right here 1, 2, 3, and 6 over 1. Those will become integers. Then 2, and then 4. So we have 12 total, but notice we do have some of them that can reduce. Namely, 2 over 2 can actually become 1, which will actually be listed right here. 6 over 2 will be 3. 2 over 4 actually becomes a half, so we can actually get rid of some of these. So let's take a look. What do we actually have? So once the possibilities are reduced, we're actually down to 8 possibilities versus the original 12. So I have 1, 2, 3, and 6, 1 half, 1 fourth, 3 halves, and 3 fourths. So these are all possible zeros. Now out of these, only some, and sometimes maybe even none, that can actually be zeros. And there are other ways to check. So let's take a look at the different examples so we can find actual zeros. And let's take a look at this example. So what we want is first find all rational zeros, and then use the remaining depressed equation to find the rest of the zeros. So what I mean by this is let's find possible zeros. So here's our polynomial, and let us list the constant term, which is 3, and the leading coefficient, which is 1. So notice the p would be factors of 3, which is positive and negative 1 and 3. That's how we got this. And q, since the leading coefficient is 1, is just positive or negative 1. So that actually helps us because we can only have integers, 1 over 1 or 3 over 1. So these are our only possibilities. Since we don't have too many of them, we only have 4. We can easily check which ones are zeros. There are a couple of ways to do this. We can either do synthetic division on the zeros to check which ones of these are actual zeros, or we can actually plug them in one at a time into the equation. If it gives us a 0, then by definition we have a 0. Like for example, I started with 1, plug it in the original equation, we get negative 8. Well, that means it's not a 0. What if we check negative 1 and so on? Negative 1 actually happened to work. That is 0, and there you go. We have our first 0. So what we can do then? We can actually do synthetic division on negative 1. And why we need to do that? Because we're going to find the remaining factor right here. So synthetic division is very easy. We just list the coefficients of our polynomial from the original equation. And so we have 1, which just comes down. There you go. And actually fix this a little bit so we can draw the arrow. There you go. And then 1 times negative 1, that's how come we get this. So then we can add, we get negative 8 times negative 1, we get positive 8. We add them again. Negative 5 plus 8, we get 3. Negative 1 times 3, we get negative 3. I'll add them up. And guess what? 0 is the remainder, which is exactly the result we were looking for. So the remaining equation, which is sometimes is called a depressed equation, is if we list them in descending form. Notice we start with 3, the constant coefficient, then x squared, and we keep on increasing. And this is how we list these coefficients. It's actually 1x squared minus 8x plus 3. And this we can either factor. So if negative 1 is a 0, that means that x plus 1, the opposite, is a factor. So here we have the factorization. Now we can either factor this part to find the rest of the zeros, or if that's not possible, which if you notice it isn't in this case, we can use quadratic formula. And so if we use quadratic formula, we plug it in and we can simplify. So if we have negative b, which would be positive 8 in this case, so if we have a is 1, b is negative 8, c equals to 3. So notice if we plug it in, we have 8 plus or minus 52 over 2. 52 we can actually factor the 4 out as 2 out of the square root. And we can simplify, we can divide by 2. 8 divided by 2 is 4, and this 2 cancels with this 2. So here we have the remaining zeros. And so our three zeros of this polynomial is negative 1 and 4 plus or minus square root of 13. So notice the only rational zero was negative 1. And that's it.